Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello students. Welcome from your Idli Fitil holiday. I believe you had a nice celebration. And at the same time, you are welcome to week 3 of our e-learning class. And for this week, the topic under discussion is model of atoms. Model of atoms. Modern atomic theory provides a reasonably satisfactory explanation of the properties of matter, the mechanism of chemical change, and the interaction of matter and energy. Such a theory emerged from the synthesis of the work of several scientists, only a few of which will be discussed here. John Dalton, who lived between 1766 to 1844, is generally credited as the father of the atomic theory, but the early Greek philosophers were the originators of the concept of atoms. They thought that matter is composed of atoms and is therefore finitely divisible. John Dalton considered the atom as constituting the simplest component of matter. He viewed the atom as indestructible, tiny hard spheres. The discovery of radioactivity by Henry Becquerel in 1891 showed that atoms are complex rather than indivisible or indestructible, but can disintegrate, forming atoms of different elements. The discovery of cathode rays in electric discharge tube in 1895 by Wilhelm Crookes revealed that negatively charged electrons were components of the atoms. This is what they are saying here before we move to the first model, which is Thompson model. The idea that matter is composed of atoms can be traced to the early Greeks. For example, there was a man named Democritus who lived around 400 years before Christ. He proposed that matter consists of tiny hard particles, which are difficult to see. He also believed that these tiny particles have shape, size, and mass. He called the tiny particles atoms. And according to Democritus, atom is indivisible. But this idea was abandoned for lack of evidence. And it was later in 1800 when John Dalton published his book, which he called Dalton Atomic Theory. And in the book, John Dalton states that elements are composed of tiny particles called atoms. Atoms cannot be divided, destroyed, or created. Atoms of the same element are identical in mass, density, charge, etc. But atoms of different elements are different. Atoms of different elements combine in simple number ratio to form compounds. All these are stated in the book published by John Dalton. And atoms of electrically charged particles called electrons. Different models have been proposed by different scientists based on their understanding of the atom. So when new truths about an atom are gained through experiment, scientists change their model of atom to suit the new facts. So in this section, we will discuss different models which lead to our present atom of concept of atom, Thompson model. By 1900, it was already established that matter consists of atoms, but nothing was known about the structure of atom. It was only known that the atoms contain electron, but that on the whole, the atom was electrically neutral. This neutrality means that there must exist within the atom enough positively charged components to balance the negatively charged atoms. This led Sir J.J. Thomson, the English physicist, to propose an atomic model which visualized the atom as a homogeneous sphere of positive charge, inside of which are embedded negatively charged electrons, as shown in the diagram below. This is J.J. Thomson model of the atom. It is a spherical object which is positively charged and inside which are embedded negatively charged electrons. So J.J. Thomson also determined the ratio of the charge to mass, E over m, of electrons, and found that the ratio of the electron to mass to be identical for all cathode ray particles, irrespective of the kind of gas in the tube or the metal the electrodes are made of. Let me quickly give you a brief summary of J.J. Thomson model of atom, as shown in the diagram. J.J. Thomson proposed that an atom is a positively charged sphere with electrons embedded in it. The electrons arrange themselves in a regular pattern on the positively charged sphere, like a plum or pudding. This is known. The number of electrons balance the number of protons, making the atom electrically neutral. The plum pudding model of the atom proposed by Thomson was successful in explaining why a normal atom is electrically neutral. 2. Why ions are formed. Ions are formed by atoms gaining or losing electrons. But the model, however, could not explain the scattering of alpha particles by Godefroy in Ginger and Madsen experiment. 2. It cannot explain the existence of line spectra of hydrogen atom and other complex gases. And that led us to another model, which is known as Rutherford model, which is also known as the nuclear idea and the planetary model. Ernest Rutherford, 1911, and his co-workers, that is Ginger and Madsen, who were his students, performed an experiment in which a beam of positively charged alpha particles was directed at a thin sheet of a metal foil. It was found that most of the alpha particles passed through the foil without deflection, as if the foil were mostly empty space. Only a few of them were diverted from their path. Some of these few actually rebounded backwards. The scattering of alpha particle by the metal foil was explained as a repulsion from a heavy positively charged nucleus present at the center of the atom of the metal foil. This follows because an abrupt change in the path, as noted for a few alpha particles of a relatively heavy and positively charged alpha particle can result only from its hitting or from its close approach to another particle, the nucleus, with a highly concentrated positive charge. All these contradicted Thompson's atomic model, which supposed that the distribution of the charges was diffuse. Hence, Rutherford proposed his model of the atom. Rutherford proposed a planetary model of the atom, which suggested that the atom consists of a positively charged heavy core called the nucleus, which most of the mass of the atom was concentrated. Around this nucleus is a negatively charged electron, circles in orbit much as planets move around the sun. Each nucleus must be surrounded by a number of electrons necessary to produce an electrically neutral atom, as shown in the diagram. The diagram shows the Thompson model of the Rutherford models of atom with a core nucleus positively charged and the electrons moving around it in the same manner as the planets move around the sun. This is Rutherford model of atom. The model was a major step toward how we feel the atom today. It, however, had two problems. According to Newtonian physics, such an atom as Rutherford would collapse by spiraling into the nucleus, since there is an attractive force between the oppositely charged nucleus and electron. That is, the electron will collapse into the nucleus because as the electrons circling the nucleus, they are losing energy, and therefore there is also the force of attraction between a positively charged nucleus and a negatively charged electron. So this force of attraction will gradually bring the electrons into the nucleus. But this is not the case as predicted by Rutherford. Further experiments indicate that charges moving in a field of opposite charge lose energy by emitting radiation, but atoms in their normal state neither collapsed nor emitted radiation. Thus, the two main difficulties of Rutherford model can be summarized as follows. 1. It predicts that light of a continuous range of frequency will be emitted, whereas experiments show that line spectra instead of continuous spectra were emitted. 2. It predicts that atoms are unstable. Electrons quickly spiral into the nucleus, but we know that atoms in general are stable since the matter around is stable. Clearly, Rutherford's model was not sufficient to explain experimental observation. Some sort of modification was needed, and this was provided by Niels Bohr. And we are going to look at Bohr's model of atom in our next period, the second period for this week. But before I will call this class off, let me quickly give you a summary of what Rutherford model is all about again. So the nuclear or Rutherford model states that an atom consists of a solid core called the nucleus, which is positively charged. The electrons move around the nucleus at definite orbit at a great speed. The mass of an atom is concentrated at the nucleus. Rutherford made the assumption to explain why most of the alpha particles could pass through the metal foil without deflection by the positively charged nucleus. Large scattering occurs when an alpha particle is passed close to the metal nucleus as indicated in the diagram. The atom must be an empty space to explain why most of the alpha particles could pass through the metal foil without deflection. Limitation of Rutherford model. The model could not explain why electrons moving around the nucleus at high speed do not emit electromagnetic radiation as predicted by Newtonian physics. 2. The model predicts an unstable atom. It says that an electron moving around the nucleus at a high speed will radiate energy, slows down, and spirals into the nucleus. If this happens, the atom will collapse, but everyday experience shows that atoms are stable. It also predicts that atoms will emit radiation containing all frequencies, but in practice, only some frequencies are allowed. Gases, instead of producing continuous spectra, as predicted by the Rutherford model, produce line spectra. And this leads us to another model which is known as Niels Bohr model. And inshallah, bi qudratillah, we shall look at Niels Bohr model in our next period. This is where we are going to end it today. When next I will come your way again, my name is Oladimeji T.A., the SS3 physics teacher of CTY Model College. Assalamu alaikum wa rahmatullahi wa barakatuh.